Good morning, good afternoon, good evening for some of you. We are on top of the hour, so welcome to this webinar delivered by Stork and co-organized with GE Digital. My name is Johan Verket. I'm Consultancy Manager for Stork Asset Management Technology, and I'm your moderator during this webinar. Thank you for taking the time to dial in the second webinar of a series we organized together with GE Digital on asset performance management. From our side, we are happy to share our knowledge with you. Of course, due to the current pandemic, most of us still work from home, hence the possibly less business background behind the speakers. The duration of this webinar is 1 hour. To avoid static background noises, we have switched off all microphones. However, we do greatly appreciate your questions. So if you have questions, please enter them during the presentation via the Q&A button at the bottom of your screen, and we will try to address them at the end of the presentations. So first of all, let me introduce today's speakers to you. We have Hans Minnaert, who is Principal Consultant of Stork Asset Management Technology. We have Kevan Esvanifard, which is our Senior Consultant of Stork Asset Management Technology. And last but not least, we have Jerem Davtian. He's a Regional Manager, Solution Architecture, Asset Performance Management of GE Digital. We have worked on an interesting agenda for today's webinar. My colleague Hans will introduce the concept of asset performance management and the various domains leading to more efficiency and long-term success for your organization. In this webinar, he focuses on the foundations for reliability being part of a potential asset management journey in your company. Kevan and Jerem will hold a very interactive and very lively presentation on the added value of a reliability program and what it can bring to your organization based on real customer cases and experiences. After the first presentation, so Hans' presentations, we'll have 3 poll questions for you to answer. We will treat the result of the poll questions at the beginning of the Q&A session. So now it is time to kick off with the presentation. Please send us your questions through the Q&A button. But without further ado, I would like to hand it over to Hans. So Hans, the stage is yours.
Thank you, Johan. Good morning, good afternoon, good evening, maybe for someone of you. Thank you for having us. What we'd like to do today is to show you the experiences we have in our partnership with GE Digital. The partnership is aimed for delivering sustainable ROI to customers who invest in the state-of-the-art APM software like GE Digital delivers. Because when you invest in such a software, it is very important that you have an accelerated adoption and a very fast time to value. And the sustainable ROI involves training and change management, and that's key to achieve that time to value. And Stork MT, we have the solutions to do so. So we work together with the customer and also together with the GE Digital in a kind of a triangle. And we deliver that accelerated adoption through training, change management, and also the interaction between the software and the practices. So we have today a use case which we will present like Kevan and Jerem will do. And that use case is based on a model, our reference model that we always use in a case like we will present is based on a standard. It's a European standard which has a risk-based inspection in it, but basically it shows you a two-fold PDCA loop. The APM outer loop. So in the APM outer loop, we define adding value asset strategies. So adding value asset strategies are aimed to reduce the risk to the acceptable level, or are compliance strategies to be compliant. So there are two ways which you can have as a source for the asset strategy. That's either compliance or risk. And then we apply the methodologies like RCM, safety integrity level, and RBI to have a definition of the value adding strategies, which are the in the maintenance loop, the inner loop. So the asset strategies will be translated into maintenance plans, which should be executed first time right and on time by maintenance. So it's always intertwined also with the maintenance workflow. So you cannot see it as a loose thing. So together with these PDCA loops, when you make them operational, you're able to achieve a sustainable ROI and a really good time to value for your APM investment. We use the software from the next slide, please, Edwin. So when we work with the software system from GE, so this picture shows you all the modules which are in that software available. Today, we will focus on the green parts of the software, in which the RCM, FMEA, and the reliability analytics functionalities will be shown, and also how we apply it. And in the other ones, the other boxes, you see the other functionalities in the software. With this software, you are really able to have one software suite for your users, for your company. And one of the biggest advantages, of course, is that you have one version of the truth. You only have one system. And implementing such a system requires, again, a lot of training and change management. Once you have implemented it, you really have a good ROI on it. And so you prevent also that people use their own spreadsheets and also get rid of all kinds of different reports and all these things. So it's a really powerful software suite. So now I will hand over to Keivan and Jerem to show you a use case which we did recently in a refinery and a petrochemical complex. So thank you.
Yeah.
Keivan, the stage is yours.
Yeah, thank you, Hans, for, your presentation. Yeah. So as promised to the participant, to the audience, we will have 3 poll questions before Keivan and Jerem's presentation. Yeah, the first question, thank you, Edwin, for putting that on the screen, is first question is, do you plan to initiate a reliability improvement project in 2021? So there are 3 potential answers to give: yes, no, or you don't know. And please don't forget to put the submit button. So still a few moments, we will look at the results during the Q&A at the end of Keivan and Jerem's presentation. So I think it's now time for the second question, Edwin. No, that's the same one. I can already start reading it, and when you put it on the screen. The second question is, do you actively use reliability analytics in your reliability endeavor? So if Edwin, if you could put the second question on the screen.
I think something went wrong. The second question is not in the system, so we have to go to the third one.
Okay, no worries. So if you maybe after the presentation we can do it, Edwin, please check. So the third question is have you considered operational excellence elements tied with your reliability endeavors? And again, you have 3 potential answers, yes, no, or don't know. So yes, no, or don't know. Please don't forget to click the submit button at the bottom of your screen. So as indicated, we appreciate to have your questions after the presentations through the Q&A button at the bottom of your screen. So please do not hesitate to do that. I think the speakers like to have also interaction with the audience, so that's a great opportunity to do that. So without further ado, I think we are now open to have Kevan's and Jerem's presentation. So guys, please give it a go. Thank you.
Yes, thank you, Johan, Edwin, Hans, for this opportunity. Good morning, good afternoon, good evening, ladies and gentlemen. Today, together with Jerem, we walk you through a success story, a real case study coming from one of our clients active in the oil and gas industries. For this client, we were supposed to look after the reliability from A to Z. That means to do everything with respect to the assets that they have in order to preserve the reliability, understand the risks, and apply any mitigation prevention activities that we need to consider. Well, the activities as such were supposed to be applicable for the greenfield, but also for a brownfield. So we have a complex, a refinery, and a petrochemicals, both in the downstream. And a dominant amount of these pieces of equipment, roughly 68,000, were coming from the greenfield, and minority were coming from the brownfield. For both of them, the question was, what should we do about the reliability of these assets? And we were one team out of several others in this project. We had the teams coming for the process safety, teams coming for the mechanical integrity, for maintenance, and for the execution. So we were one out of several team members. And as I said, we were asked to handle the reliability risk. Of course, cost effectively and holistically. Now, I'm going to walk you through how did we do this activity. And as I said, because we had a greenfield as the dominant, so we started conventionally, we started from asset criticality analysis. Why? Because we should know where to begin with, all right? And that means we went through all the steps of the analysis in order to understand what are the most critical assets. Quite simple. We put the backbone of the reliability into the foundations of RCM and FMEA, even though we know that they are time consuming. So we should be aware that, okay, what should we do with respect to that time requirement? So we should have a strategy for that, right? In addition, we were supposed to look after the risk also quantitatively, right? So RCM, FMEA are quite good methodologies, but they are not as quantitative as the reliability analytics. We were asked to use the reliability analytics tools and methodologies as a supportive methodology. Same when it goes into the spare part analytics, not only to identify the types of the spare parts, but also to apply the spare part analytics in order to calculate the min and max, the reorder point, the reorder quantity, the risk of stock out. Of course, as any other project, we were supposed to define the KPIs, at least for our own domain, for the reliability domain, to identify the success and failure within the journey, but also by the delivery, right? And nothing is perfect, including our activities. So what if something goes wrong, right? So the backbone for the methodology we put into
Yes, I think we lost Kevan. Maybe Hans, can you cover this part or?
Yeah. I will take over for Kevin will be back soon. So what we do is define the success criteria KPIs, as Kevin mentioned, and also the learn lessons by applying the methodologies like RCA. So we complete the PDCA loop in terms of setting the strategies, but also evaluate the strategies. So closing that loop is very important, of course, that you are able to have also the strategies implemented. Next slide, please.
I'm back, Hans.
Okay, thank you. You
Sorry.
take it, okay, one.
Yes,
Yeah.
I'll take it over if I have no other interruptions.
Okay.
Good. So I told you that we had 68,000 pieces of equipment. Here we call them tags. All right. And we applied asset criticality analysis in them. The first user for the asset criticality analysis was supposed to be the reliability team, but also we had teams of mechanical integrity and process safety waiting for the result of asset criticality analysis in order to start prioritization where they would like to begin with. Now, looking at this pile of work that we had, we thought, how should we start? And how should we look at this activity, right? So we thought maybe the first and the primary step is to preserve all the assets that deserve a minimum level of attention. And we call that minimum level of attention basic care. I know in ISO 14224, it is called casual maintenance. So imagine it's about all the activities that normally operation is supposed to take care of in their daily rounds. Such as visual inspection, such as tightening, such as lubrication, refill or top of oil, abnormal noise, abnormal vibration, excessive heat, etc., etc. But we developed a library for that per object type. What are the tasks? What are the frequencies? Who is supposed to look after them? So we went deeper. Then when you set the stage, next level is what should we do with the minimum, with the medium criticality? So the assets that are not very high critical, but they deserve more attention than the basic care level. So that is what we call the standard care. And the standard care activities are activities for which we need instrumentations and further training, like vibration analysis training, ultrasound, thermography, oil analysis, or when it goes to the electrical equipment, partial test for the transformers or standard test for the AC motors, for example. Again, all tasks, all frequencies, and all owners, one after the other one. This is the platform that now we can set the stage and spend ample time to attack the high and very high critical tags using RCM and FMEA with multidisciplinary meetings. All right, so that we had enough time to go over them thanks to this foundation. All right.
Yep. Thank you so much for that, Keva. So it is very important, and this is Jerem of GE Digital. Dear attendees, thank you so much and welcome to this webinar. So Keva, thank you for this introduction. And I wanted to demonstrate to you on a high level the solution that Keva and the team used to conduct this particular study and to conduct this particular analysis. So what you see on the screen is an example of GE Digital's asset performance management solution, also known in the market as Meridium. And we basically recommend the teams, whoever do the criticality assessment, to follow the risk matrix approach. That is the one that will allow us to formalize what categories, consequences, and the probabilities of risk that we're using. And as an output of that, you would have the asset criticality distribution as an immediate value driver. This will help you exactly to prioritize on which assets you would do the basic care, the standard care, or the optimal care, as Kevin has just explained, by calculating the total risks and breaking down the assets by their priorities. Now, furthermore, the immediate results that the asset criticality analysis can visually present to you is the effectiveness of what you're doing in terms of maintenance strategies today. So what we have here is on the horizontal axis, we have remaining unmitigated risk. And on the vertical axis, we have the annualized strategy costs. So if we compare those two, we can very quickly highlight and we can very quickly see where do we need to refocus our attention. For example, if you look at this asset on the top level corner, what we see is that it has extremely high annual maintenance costs, but relatively low unmitigated risk. Is that the one that is really over maintained, and should we look deeper into what drives our activities there, as opposed to this asset on the bottom right, where we see very high unmitigated remaining risk but almost no maintenance expenditure? That is probably one of those assets that is under maintained. So expect surprises and expect the unplanned failures and a lot of reactive work specifically for this asset. So when you visualize these results, it is evidence that something needs to be done about that, to review and to reconsider the activities. So Keivan, could you please explain to us and to the audience, based on your experience in the projects that you've done, what would be the next step, and what would you do to improve that?
Yeah, so we are talking about the larger scale project. It's not about 100 pieces of equipment and ample time to address them, right? So from the very beginning, we set the stage in a way that any service and activity that we offer to the client should be lean. And what do we mean with that? Okay, we start from the criticality, and we know that thanks criticality, we will pay enough attention, not too much or too little, into the assets. Okay, that's the outcome of criticality, not us, right? However, what matters next is we are not single in this project. We're working together with other teams, other disciplines, for possibly the very same object type. Take a heat exchanger, for example, static, but also we as reliability engineers do something about loss of containment about them or about the reliability of them. So which failure modes should be addressed by the RBI team or mechanical integrity team, and what is left for us? That should be very clear from beginning, right? And the same goes with the process safety, like the detectors, for example. The same goes for compliance, quite important matter. Who is going to look after the tests? And what about the spare parts for example, process safety elements, right? So that should be very clearly set from the very beginning. And in order to be lean, we should also take into account that internally, but also together with the other team, we should not forget that consolidation and linking of all these recommendations is an important step ahead of the gatekeeping by the management. And this is something that we had the opportunity to use the module of ASM of GE in order to look at the broader picture. Jeroen will walk you through that. The other highlight that we emphasize from the very first day is that whatever we deliver to the client should be at least in the level of an international standard. This is what we did for criticality. We followed the NORSHOC standard. When it comes to the RCM FMEA, we were compatible with ISO 14224, with SIE, with IEC 60300, 311, dependability management. And remember, I told you that we were coming from a greenfield mainly, so the greenfield doesn't have too many failure history. So what did we do about it? We reached out ORADA database, and also we reached out our own libraries in order to identify the dominant failure modes and the failure mechanisms that must be addressed in cases that we didn't have a history. We did everything in a multidisciplinary study when it comes to RCM FMEA or when it comes to basic and standard care, together with maintenance, together with operation, and of course the reliability team as the host. Why that matters? Something about 70%, according to some research, something about 70% of shortages in OEE, overall equipment effectiveness, can be addressed to the way that we operate the asset. So reliability has a lot to do with operations. And that's why we developed the idea of operator-driven reliability, ODR. So how to handle that together with operation. So if I want to summarize, as the delivery point, what did we do? When we finished the criticality, as the first attempt, we ended up into a rough delivery, 40% of high and very high critical tags. And you can imagine that's a large amount of workload when it goes to the next step, RCM FMEA. So we refined and retuned the criticality analysis. We moved down from the system subsystem level into the object type level. And thanks to that, we reached out to 26%, which is still slightly more than the rule of thumb that we have, which is 20% for high and very high, but acceptable to begin the next step. Thanks to basic and standard care being in place, we have a relatively small amount of recommendations coming out from RCM and FMEA. So 2,500 recommendation for this large amount of pool is negligible, right? So we didn't spend a lot of time in RCM and FMEA, you can imagine, but we developed quite good and sharp to the point recommendations. We also identified some 30 recommendations that are addressing design change for a greenfield. I know many companies ignore that part, but we considered that, right? And in the end, we left a pragmatic process guide in order to align everybody with all the responsibilities when it comes to why and when and how to apply all these methodologies. All right?
Awesome. Thank you very much for that, Keivan. This was a huge effort that you have completed for this particular activity. And dear attendees, this is the solution that Keivan and the team have used. What we see on the screen is an example of the GE APM's strategy management workflow and the summary workflow, where here, basically on these visualized dashboards, we can very evidently see the status and how we're progressing, how many strategies are still being drafted, how many are being done. We can obviously see what is the source of the recommended changes, the RCM studies or the RBI studies or the HAZOP. So what does drive our newly built actions within our strategy? What types of actions they are? Majority of them are condition-based, very good. Some of them are time-based, some of them failure finding, which is also good, and some of the redesign, what Keivan has also mentioned before. And of course, what do we do and how do we implement those actions? This is also a very good progress tracker for you, where you could basically see, which actions would fall under the operator rounds or the PMs to be done in the SAP, or condition assessments, policies, health indicators, etc. They're all combined in the tool that is called the Strategy Manager, where we would see all the relevant activities applicable, driven from various types of analysis, RCM or FMEA, whatever that would be, for a given asset. And then once we compile all of these actions together, it's important for us to build the optimum combination of these. Because remember, we're pursuing two major goals. We want to reduce our costs, but at the same time, we want to maintain the low level of the risk, right? So we don't want to overspend on our maintenance. So strategy optimization feature really allows us to look at the various scenarios of which maintenance actions or recommended actions we can do or we could potentially skip, to immediately see the representation of what that means for a risk profile. For example, in this particular case, by not doing some of the tasks, we're actually increasing the risk by 3%, but we're saving 13% of our annualized maintenance costs. Is that good enough or not good enough? That is really entirely your decision as the asset owner. So the technology and the services here really provide us and help us to visualize and help you come up with the right decision. So a lot of these decisions are also driven by the relevant methodologies that were closely related to that, related to the mitigating factors. One of those that Keivan previously mentioned was the spare parts analysis. So Keivan, could you please explain to us a bit more on what spare parts analysis is and what kind of analytics could you offer, what you've done for that particular project, please?
Sure. Thank you, Yoram. So when it comes to the spare part analysis, the first step is the categorization of the spare part. And you have at least two criteria to begin with. One is cost or expenses of the spare part, and the second time is lead time or the delivery time of the spare part. With these two criteria, you end up at least into four categories, right? So you have consumables versus strategic spare parts. Consumables are shorter in the lead time and normally quite cheap, right? So you can name bolts and nuts and oils, for example, lubrications that you have. They are available in the local market, and they normally do not need a lot of attention from the reliability side, but from the warehouse. Then we have non-critical versus critical, which are the opposite, of course. So if you identify the critical ones, then you know what about the non-critical ones are. So we had a certain criteria to meet the critical spare part criterion. And what were they? So they should have been addressed or recommended, first of all, by the RCM FMEA. If not, that means they should not be critical. Second, we defined a certain level of risk, a threshold, which below that, we don't call a spare part critical, right? So you can name medium, or we have an RPN, risk priority number, that we call that number. And if it is below, it's not critical. And second, we looked after the commonalities. So if you have a number of pieces of equipment quite identical, do you need to buy a spare part for all of them, one after the other one, or do you have a minimum number to calculate? And this is the calculation that comes next. The last point is about strategic spare parts, which are very low in the probability that you need them. But once you need them, then the lead time is quite long, and the expenses to procure them is also considerable, right? You can imagine we talk about charge gas compressor rotor, for example, that may take 6 months to be delivered to you, if not longer. And within that period, the whole plant stops. So nobody would like possibly to take the risk. We clarify all those criteria with the management, whether they accept or not, right? That part is about categorization. This is an easy step. Next step is about analytics. And that is where the delivery is coming from, right? So in the analytics, we first spoke about all these categories, but also we walked through all the steps you need in order to calculate. We formulated everything simply in a process guide, so it's transparent for everybody, right? How to do it and how to refine it. We went through the reorder point calculation, reorder quantity calculation, and the risk of the stock out manually. And we use the GE Digital software in order to help us to identify the optimum stock quantity. And we practiced all together with the clients, all these steps one after the other one. And surprisingly, we could save a lot of money just because of that practice, unlike 10 pieces of critical equipment. Right, Yerem?
Yep. Thank you so much for that, Keivan. And the tool that the team has used is the spare parts analytics capability within the APM solution by GE Digital. So what this capability and analytics is, really, it's about assessing and calculating the risks that your organization will face, depending on how many of the critical spare parts and the strategic spare parts you would keep in the stock as a minimum safety stock. So for each spare part, typically what is being assumed is the application where the part is being used, and hence the population of assets that work in a particular application. Then there's quite a bit of a statistical analysis that is being engaged here as well, with mean time between failures, mean time between repairs calculations for various applications. We would certainly consider the losses due to stockouts, the cost of holding and the cost of buying. And as an output, this Monte Carlo simulation runs thousands of scenarios to give you a following way of an output. So horizontal scale really represents the number of assets that you would have, and the vertical scale represents your financial risks, or the cost in other language. So what we're saying here basically is, and out of the simulation results, if you have 0 on hand, then you would have a relatively average proportion, which is the yellow piece of the bar, of the cost of holding, cost of direct maintenance, but you will face huge costs and the losses due to the downtime because of the stockouts. If you have 1, of course, your fixed cost will not change, but the variables will be the variable risk. So your stockout losses will be significantly less. But as you can see here, as long as you have 2 or more, your financial risks are minimal. Now, what that means is that it's really entirely your commercial decision based on reorder levels and the optimal order quantity, whether you want to buy 4 or 10 or 15. But importantly is, as long as you have 2 or more, your risks are minimal, and the risks of you facing the significant costs and expenditure and the losses due to the outage are going to be minimized. So, of course, in order to simulate those results, there is quite a significant level of analytical calculation in reliability analytics that happens behind the scenes. So, Kevin, could you please talk a little bit more about the reliability analytics and the methodologies that are being used, please?
Yes, Sure. So reliability analytics is one of the areas that you cannot go deafblind if you have no software. And we had the chance to use the Digital software, all modules, including these 4 that you have on the screen. So use reliability growth actually as a live indicator for you to check out what happens with all the changes in the scenarios and in the recommendations that you have. How does it reflect your level of reliability in the asset level or in the plant level? Doesn't matter. When you talk about failure distribution, you look backward actually and look at how you can model all the failures that you had, right? And how you can learn the lessons for the future, for the regressions that you have for the future. When it talks about the reliability distribution, you mainly speak about time to repair and time to failure distributions, and check out the sensitivity of them with respect to the scenarios that you have developed. And finally, the most complete one is, of course, the reliability block diagram, where you can call all of those outcomes of the other modules into and set up one or a number of scenarios based on connecting different pieces of equipment together and measure the downtime or the reliability or the expenses of the failure. You have the possibility to use multiple different distributions. 4 of them are here. There are more. So viable, like normal, normal distribution, which doesn't have a large popularity in the area of reliability, exponential, extreme value. Those are among the possibilities that you may have. What matters more to me is, of course, the software helps you statistically to choose the best fit for your distribution. However, we as a user should have a minimum level of knowledge to understand what distribution matches with what failure mode most. And therefore, when we have a suggestion from the software, we can judge about it, right? This is what we stressed upon and we practiced a lot on. So that brings me to the deliverables. What we delivered, first of all, and to me the most important, is a platform. Set the stage in a process guide to talk about why and when and how, so that everybody comes to the same place, even though he or she is a beginner. We also practiced it together with the client. We again took another 10 pilot cases, pieces of equipment, and we practiced quite a large amount of distributions and models and modules in order to understand how they work and what do they give to you and what they don't give to you, and you should have on your own. All right, Jeroen?
Excellent. Thank you very much for that, Kevin. And dear attendees, here's the visual representation of reliability distributions as part of the reliability analytics offering. So essentially, all we need for the models to run is the history of failures that has typically been taken from your CMMS, being that SAP or whatever the solution you use for recording those. And then it's the basic, well, not basic, but advanced, but the standard reliability distributions and time to failure distributions that are being calculated for us to come up to some of the very evident outcomes. For example, well, those of you statisticians, if there are any statisticians here who would know how to interpret that, what you would find that the calculation indicates that the beta shape factor is more than 1. That means that there is a particular time after of the operations of the asset after which the probability of failure increases. That means that if there is any particular wear out pattern, then doing a preventive maintenance in the most optimal time period is something that makes sense. Again, the software will allow you to calculate this most optimal PM interval so that you can use that source of data to be later followed within your strategy development, so you can figure out the most optimal intervals for the maintenance. Furthermore, we can look at the reliability growth studies. This is the one that really helps us shape and understand if there were any predictable patterns and identify the points after which things have changed. For example, if we see how the mean time between failures trend for a given asset has been changing over the past course of a few years, we can see it started from a relatively high, probably the asset was brand new, but then we were obviously doing something very, very wrong. And every year, the mean time between failure was degrading. So a change happened in 2006. Most likely we've looked at that carefully and we have seriously reconsidered the way how we maintain, predict and prevent those failures. We must have changed the strategy. And after that, we've seen that over the years, the mean time between failure has been steadily increasing for this particular population, which is exactly the result we want to see. It may not be as good as new, but nevertheless, it's a significant improvement from what it was before when we started this reliability journey. And there are other elements of the reliability analytics I wanted to show you is the system reliability analysis that Kevin referred to. This is where you would simulate various configuration of your system, right? Some assets go in parallel, in sequence, some of those systems go in parallel. What's important is that the mean time between failure and mean time to repair is calculated for each of those assets. And then depending on how you simulate scenario 1, for example, this is how the assets are being configured. Scenario 2, maybe they all go in sequence. Scenario 3, you will need additional parallel standby here as well. This is really, up to you to simulate those. What's very important, and I mean, this tool is very widely used during the system design or redesign, but what's important is all these calculations are summarized for you. So for each of the scenarios, you would know, again, Monte Carlo engine helps here to understand and anticipate number of failures, downtime days, most importantly, the costs anticipated that will incur, reliability and availability metrics, as well as many other ones of those. So looking at those detailed simulation results, I guess it's for you will be very evident to figure out what exactly is the scenario that really does make sense to you, and what would be the expected trends in terms of costs and in terms of the risks for this combination of assets. So this can also give you a significant input in your reliability in design, whether this is done as part of the greenfield or whether this is done as part of the redesign. And with that, that's going to be another input in your RCM studies or in the studies of how you design your system in the first place. But when we eventually assess the success of how we have been using and utilizing these assets, there is the next step of the reliability studies that we typically reach to, which is the root cause analysis. So, Kevin, could you please highlight your experience in delivering the root cause analysis studies for your customers, please?
Yeah, sure. So when you are in the reliability, you cannot ignore that one way or the other, you may have some failure modes that running out of your control. Either you didn't recognize them when you were doing your RCM FMEA, or they are a matter of a mistake done by a human, by the way of operation or whatsoever. They are inevitable. So the first question is, we should set the stage and know what to do far before it happens, because when it happens, everybody rushes into a conclusion or a solution to improvise to get rid of that problem, right? So for us, the first step is to be lean, to be clear. What to start, how to start, who's responsible, what is the timeline, what are the thresholds, and who should be responsible for each and every delivery. To be lean in the RCA area. The second, again, is we would like to be distinct. We would like to be at least aligned with the international standard. This area is driven by IEC 62740, and especially from that standard, we hang on the event tree analysis, the logic tree analysis, and the simplest version of the logic tree, which is the 5Y for the light cases. So these are what we develop further and practice together. Next to that is about the recommendations. So the journey doesn't end by just issuing the recommendation. We should make sure that what happens next. Are they going to be implemented? Are they going to be successful? And what is the recurring time that we don't accept? And what do we count as the repeated failure? So everything should be detailed enough. Otherwise, it goes out of your control. And apart from all the technical complications, we have some soft biases on the way forward. Imagine that people are put or feel that they are put around the corner and they would like to be free. They would like to know how they can get rid of that problem, how they can solve that problem. They may improvise something, they may hide something. So the facilitator, the team lead, the sponsor, the team members should be aware of those biases and should have tools in their hand in order to manage them. This is also what we practiced together. So as the final step, as the delivery, again, we left a pragmatic process guide in order to handle the soft issues and the technical issues. We defined, or we suggested, the roles and functions and the framework that should be further clarified in the procedures of the client. We trained multiple different facilitators, and also the team members. Team members of our CA should also be trained to understand what is their role and what are the expectations from them. And then we practiced several root cause analysis together in different level, and we coached quite a number of them. Yerem?
Yep, awesome. Thank you so much. So to simplify the process of doing the root cause analysis, to make it automated, the RCA specific tool is being used in GE Digital's APM solution, where as you're progressing, you can track the success of your root cause analysis studies by looking at where you are with your recommendations, because any results of the root cause analysis is to implement the changes that do make sense. As well as that, what were your findings in terms of what types of causes you have identified? Which ones of them were more related to the physical asset failures or human causes, or most importantly, something that we call the latent causes, which are the organizational or systemic failures. And the root cause analysis is part of the bigger practice process that is considered but not limited to identifying what the failure is, by which asset is a candidate for your analysis. This could be done as part of the bad access studies or health indicators that tell us what asset requires our attention right now, or like we've discussed before, the trends of mean time between failures. When the root cause analysis is done, we support either a full logic tree with a very detailed study to look at every potential hypothesis, evidence to validate or disqualify each of them, or a simpler 5-why approach for the study, for a simpler studies. Like we said, most importantly is the identifying what recommendations should take place. And like Evan said, we don't stop there. We want to make sure that the results are tracked. And if the RC analysis has been done to a good process, we will see change in the health indicators and in the bad actor studies. So Evan, what happens next as the results and as the summary of this exercise?
Yes, so if I want to summarize, and if I want to highlight the most important deliverable that we had was about the team, about the champions that we trained. So we trained dozens of people who are inspired, engaged, and empowered enough to carry on this journey. We will not be there the whole time. This is up to these champions in order to continue this journey. We're happy to have them on board. The second is that we had a considerable improvement in the team working, multi-disciplines within maintenance, between maintenance and operation, maintenance, operation, mechanical integrity, process safety team. All together, they worked for a long time and they delivered a lot. This remains with them. Whatever we delivered, we committed ourselves to make it auditable and upgradable. So we wrote down all the failure modes that we could identify, all the mechanisms of failures that we could identify, just aligned with ISO 14224. And we wrote out in scenarios in a way that they can be audited next. Now, as I said, we tried to put the foundations not only qualitatively, but also quantitatively. We practiced that together, and that would be a very solid foundation. We delivered everything in a time shorter than planned. 3 years planned, 2 years delivered, the whole journey so far. And in the end, the most important one for managers might be the payback time. And that was shorter than a year. Actually, for the brownfield was a year, and for the greenfield was shorter than 6 months. Yerem? Yes, and one more point here is about what about the next step? What about the way forward? So the first step forward that I see when I come from the reliability is with respect to the unidentified failure modes. We will definitely have a number of them. So we should hunt them on the way forward. The second point is with respect to the gray territories, to the areas that nobody exactly knows what to do about. Imagine we talk about spare parts for the process safety management, who is responsible for the calculation of them. Spare parts for the static equipment. There are few, but there are something. So who is looking after them? All these gray areas should be addressed, and we have listed them. Continuous improvement, so continuing this journey together with these champions and involve more people into this journey is a matter to be considered for the future. And the last but not least is about sustainability. We reached out the elements of the operational excellence. And that means we are not the only one who sets the level of this operation. So we're working together with the energy intensity team, the quality team, the APM works together with EHS, threats, and process safety management, together with operation. All of us are responsible. How to improve this balance? That's not a question only to reliability, it's a question to the whole team.
Thanks very much, Kevin. I really love that you mentioned the words sustainability and continuous improvements. So the technology always allows you to go back and close the loop and figure out what else could be improved. After you've done all these analysis, are your assets really healthy? Are there some more that require your attention? You know, going back to the uncovered failure modes that Kevin had just mentioned. Or there could be a different angle we could look at. What assets still do drive our costs? What are those bad actors? Let's focus on those and let's figure out if there is any other opportunities to improve availability and reliability there. And again, comparing your availability across sites. If you're a big organization with multiple sites, that's clear enough. If you're a one-site operation, then comparing how your different departments within the team works. And it's obvious, it's evident here that this orange line is the one that's we can look at as an main improvement pattern. In summary, I just wanted to say that what's most important is that we have spoken today a little bit about the criticality, the RCM, and identifying the risks and actions and building the strategy. We've also spoken a bit about root cause analysis and reliability analytics. What we would like you to invite, the previous webinar was focused around mechanical integrity, right? And there's going to be next webinars that will address multiple other elements of our end-to-end improvement workflow. What's important as a summary, I want to really recommend all the attendees is to consider this as a continuous improvement loop. So whatever you do the reliability or root cause analysis studies, there has to be an output which typically feeds as an input into reviewing the existing strategies and looking at further ways how to optimize your operations, maintenance, and reliability. Thanks very much for your attention, dear attendees. Johan, let me hand it back over to you to take our questions. Thanks very much.
Yeah, thank you, Kevin and Jerem, for this very interactive presentation. I liked the interaction between both of you, telling it from the process side and let's say from the technology side. We have still 8 minutes left, so I propose to skip for now the poll questions, and we have had a lot, and that is obviously because your presentation was very exciting and very good. We had a lot of questions, so I prefer to go to these questions before maybe we will show the poll results. So one of the first questions was, and I think that's for Kevin, is that what is the definition of a tag? Because you talk about 68,000 tags. Is that equipment? Is that part of an equipment? Just for the knowledge, what is a tag?
Yeah, you can call it equipment or you can call it a functional location. But most of the time here with the client, we call it just tag. Some clients call it item, but it's just one lower above the component level. If it makes life easier for all of us to understand, that's what we call tag.
Okay, thank you, Kevin. We had another question about if you look at the distribution of standard critical and high critical tags, what was the distribution in the case of this customer?
Yeah, so maybe I can answer that. We had in the end something about 25-26% high and very high. We had roughly about 20, maybe 5% or a little bit more medium, and something about 50% left were all low critical.
Okay, thank you. Maybe a question for Jerem. Could you tell us if this system also works within the nuclear industry?
There is no reason why it shouldn't, and I believe we have had experiences with the nuclear industry to enable our solution. There is one element that is very applicable to the nuclear industry that we haven't covered as part of this particular workshop, but it could have been covered as a part of the other ones, is looking at the asset safety and doing the HAZOPs and the safety instrumented system studies, identifying layer of protections and defining SIL levels to mitigate the risks. This is another very strong functionality which is specifically applicable, well, functionality in the work process, which is particularly applicable with the SIL level 4s to the nuclear industry, which we have had history of doing that before. Thanks.
Okay. There's one question. Yeah, maybe Hans, you can respond to that. So there was, let's say, noted that the process of this project took around 2 years. And what about the team size? Yeah, the people were involved, the client's involvement, and what are the team qualifications that are required to do such a project?
Yeah, so yeah, we started the whole project 2018. Then we, of course, we had to man up the team specifically for the reliability. Was roughly 4 to 5 people. It depended on the workload. What we did in general in the project, and that's proven very successful, is to have pillar leads, as we call it. So we per main section of the project for reliability, mechanical integrity, safety, we had a pillar lead. K1 is the pillar lead for reliability in this case. So the reliability from our side varied 4 to 5, one time even 6. And then, of course, from the client side, we involved the reliability engineers during the RCM sessions, but we also have the champions. So on the client side, we installed so-called champions, which we trained extensively in 2 stages, basically. The first stage was the basics for what we are going to do in the projects. And now we are also have extensive training to give them the competence to bring it further after we leave the site, so that they can bring it further, that we only have maybe a role for kind of QA, QC. So on average, I think for the whole project, including mechanical integrity and process safety and the whole training, our team was sometimes 10 to 12 people in total. So that's for the whole, but that again varies very much with the stage we are in, and also what is the input from the customer. So what is the competence on the customer side? So that's roughly what we did.
Okay, because it was a joint effort after all, with the customer.
For sure, yeah. That is the main message. Is we engage with the customer. One final remark to that. So usually we say we do 1/3 of the work, and we do the work. Then we have 1/3 where the customer does the work, and we coach them and help them and train them more if needed. And then the last 1/3 of the work is done by the customer on its own, and we have a role like QA, QC, and some coaching, and when there are questions. So that's also the basic setup of such a project.
Okay, thank you, Hans. Maybe a question for Keivan. Do you consider in the top of the pyramid, we showed that on one of your slides, I believe, the single point vulnerability equipment and very special spare parts?
Yeah, if you mean very special spare parts, you mean strategic spare parts? Not always the case. But the point of vulnerability, yes, of course. That's why they are assigned to be very high critical, and that's why we spend an ample time using RCM and FMEA in order to identify those risks and either prevent or mitigate those risks. But it should be called a vulnerable point if you ignore it, and we didn't. I think we paid enough attention for that. So now it's the point of strength, because we had no bad actor coming from the top of the pyramid.
Okay. Thank you. And maybe we are close to the end of this presentation, and I propose that we will, for the people, the diehards who still want to see the results of the poll question, can still stay in the presentation. But I have one final question for Jerem. So is it possible with the GE Digital APM tool also to perform RAMS analysis?
Absolutely, yes. Reliability, availability, maintainability study, and the foundation for that really is the system reliability studies, which I think we have shown. So assessing the reliability and availability of each element and of the whole system overall, this is part of something that would be very essential for designing the relevant system to mitigate the risks.
Yeah,
I think there is a lot more we can say on this subject. So please, for any follow-up, feel free to share it and reach out to us, and we're more than happy to address that question in more details.
Okay, thank you. So this is there are still we get a general question if this presentation will be made available. Yes, there will be also. These are also this session is also recorded, so you can rerun the presentation through YouTube, so it's recorded. The rest of the question, because we have had a lot of questions, will be answered by the different speakers by email. So that you can count on. So for now, I would like to close the presentation. Thank you for the participants for your time today. Thank you for all the speakers and in front of you, but also Edwin, who was behind the buttons to make this happen. And I would like to have one last request to Edwin to show the poll results. So then, yeah, for the people who want to stay. So the first was, do you initiate a reliability improvement project in 2021? Well, that's a good result. So almost 50% would like to do a reliability improvement project even in 2021, and we are almost half of the year. So that's good news. Maybe the second question, which we didn't have in the beginning, and maybe if there are still people available, can still provide their answers. So the second question is, do you actively use reliability analytics in your reliability endeavor? So please make your choice. And we will show the poll results directly after this. So yes, no, or don't know. I give you a few seconds to respond to that question. Yes, and Edwin, can you show the results? Okay, that's also a very high number. So that people are already doing reliability analytics in their reliability endeavor. And then the last question: have you considered operational excellence tied with your reliability endeavors? And there you also you see that a lot of people are connecting operational excellence with reliability, which is a very good thing, obviously. So with that, I would like to take the time finally to thank everybody for attending this session. As mentioned before, we will have a third one coming up after summer vacation. So I hope everybody will have an energizing summer vacation, and we see you hopefully back again after summer vacation for our third session. We will organize again together with GE Digital on asset performance management. Thank you and have a nice day.